Welcome back, guys. Right, so just in continuation to our earlier video, I said if you break down a particular number or a cube number into its prime factors, right, then you can find out the square root by looking at the number of times the prime factors appear in the cube. Okay, adala you have to understand it very clearly. I gave an example that a particular number, when it is broken down into its prime factors, you had 6 3's being multiplied with itself, 3 into 3 into 3 6 times, and 5 multiplied with itself 3 times. Okay, then the number of 3's in square root will be nothing but the number of 3's in the cube. Okay, number of 3's in the cube divided by 3. See, the number of 3's in the cube root, I mentioned it as square root, right? So I'm sorry for that. The number of 3's in the cube root is nothing but the number of 3's appearing in the cube number divided by 3. Please listen to it carefully. I am saying number of 3's appearing. Okay, I did not ask you to divide 3 into 3 into 3 6 times divided by 3. That is not what I am asking. Because if 3 into 3 into 3 6 times, right, when you divide by 3, you will get 3 into 3 5 times, isn't it? Right? I am not asking that. See, the number of a prime factor in the cube root will be equal to the number of prime factors or the number of that particular prime factor appearing in the cube. Number of prime factors appearing in the cube divided by 3. So if the number of a particular prime factor in the cube number is 12, the number of the same factor appearing in its cube root will be 12 divided by 3 4 times. Okay, so this is what I have been saying. So please keep this in your mind while calculating cube root. Let us observe some of the numbers. Okay, so you take numbers from 1 to 10. Let us analyze the cube of these numbers. 1 cube is 1 multiplied with itself 3 times. You get 1. 2 cube equal to 2 multiplied with itself 3 times, which is 8. What is 3 cube? 3 multiplied with itself 3 times, right, which is 27. What is 4 cube? 4 multiplied with itself 3 times, which is 64. What is 5 cube? 5 multiplied with itself, which is nothing but 125. See, the moment you come to 5 cube, the cube number, the result, exceeds 100. Okay, so how many numbers whose perfect cube lie between 1 and 100? There are only 4 numbers, right? 1 cube to 4 cube, right, lie between 1 to 100. Now, likewise, you start putting together cubes until 10 cube. What is 10 cube? It is 1000. So, what is that we can infer? There are only 10 perfect cubes between 1 and 1000. Isn't it? There are only 10 perfect cubes between 1 and 1000. Right? And you also look at the unit digit of the cube. So you take any number that ends with 1. The unit digit, right, of the cube will also end with 1. When a particular number ends with 2, the unit digit of its cube will end with 8. Okay. So when you have unit digit of a particular number 2, the unit digit of its cube will end with 8. When the unit digit of a particular number ends with 3, the unit digit of the cube number will end with 7. When the unit digit of a particular number ends with 3, the unit digit of its cube will end with 7. When the unit digit of a particular number ends with 4, the unit digit of its cube will be 4. Okay, so when the unit digit of a particular number is 4, the cube of that particular number will have in its unit place number 4. Okay. When the unit digit of a particular number is 5, the unit number or unit digit in its cube will also be 5. Right? When the unit digit of a number is 5, the unit digit in its cube will also be 5. When the unit digit of a number is 6, right, the unit digit in its cube also will be 6. Okay. When the unit digit is 7, right, the unit digit of its cube will be 3. Right. See, there is a relationship. When the unit digit is 3, the unit digit of its cube, right, is 7. When the number is 7, when the unit digit of a number is 7, then the unit digit of its cube will have 3. Similarly, the unit digit of 8, right, will have in its cube the unit digit as 2, right? The unit digit of a number, right, when it is 8, the unit digit in its cube will be 2, right? We said earlier, when the unit digit is 2 for a particular number, the unit digit in its cube will be 8, right? There is a correlation. When the unit digit of a number is 9, right, then the unit digit of its cube also will be 9. When the unit digit of a number is ends with 0, right, then the unit digit of a particular cube also will be 0. So when we talk about numbers of the form 10, 20, etc., right, you have 1 0 in 10, right? So 10 cube will have 3 zeros, right? In the case of squares, we said if a number ends with 0, right, then the square will have 2 times the number of zeros appearing in the original number. In the case of cubes, if there is a number with 0, right, or ending with zeros, okay, then the cube of that number will have or will end with 3 times the number of zeros that the original number had. Okay. So again I am saying we are only talking about numbers that ends with zeros. Okay. In the case of 102, we cannot say there will be 3 zeros. Okay. All right. Right. Only when a number ends with zeros, right? Like 100, 20, 30. These are all ending with 0, right? So you look at the number of zeros that it ends with, the cube will have 3 times. 3 multiplied by the number of zeros appearing in the original number. Okay. So these things you just remember, because this will be useful if you have to figure out a particular number is a cube or not, right? Or at least estimating cube of a number. You know, if there is a number 121, and if somebody says, okay, the cube of 121 could be 37248, you can immediately say it is not a cube. Because when a number ends with 1, then the cube also will end with 1. The unit digit of its cube will be 1. So you will be able to quickly, will be able to arrive at a judgment, looking at the unit digit. Okay. So that is why, we have to just keep in mind, so that at least, we will be able to estimate, and we will get a right direction in terms of approaching a particular problem. All right. So in our next video, we will discuss about yet another method of finding cube root. Very, very interesting method. Okay. Wait for my next video. In case if you have any doubts, right, remember to send email, right, to askmentorguru@gmail.com. ask mentor, mentor, guru, guru@gmail.com. All right. Please remember to subscribe. Please click on the bell button. All right. That will give you notifications as and when we upload videos. Kindly give your recommendations. If there are certain improvements that you are, you are seeing in our videos, you have a good idea. You feel like, if you do such and such things, right, it will improve the quality of the lessons. Kindly, either put in a comment or send in as an email. Right, I really appreciate one child that actually put in my first video a comment saying that, sir, can you switch off the fan, because I could hear fan's noise, right? I really appreciate that comment, right? I really, really appreciate that comment. And in fact, I replied back, to that child saying that, yes, from the third video onwards, we have switched off the fans, right? There will not be noise anymore, from the third video. So kindly bear with us for the first two videos of rational numbers. So likewise, if you have any recommendations to be given, any feedback to be given, kindly give, because we are uploading these videos for the overall benefit of children, So it is not just my responsibility, it is everyone's responsibility. There may be good teachers out there, right, who may listen to my video and would say they would like to add to what I am saying. Kindly record the video and send it to me. I will upload it, because this is not a commercial activity, right? It is basically to ensure that we assist our children, right, our sons and daughters, to excel in their studies, right? So whatever recommendations you have, if you want to contribute videos, send it to me, right? I will upload it, right? Because we have to provide this service together. This cannot be done with only few hands, so it has to become like a movement. So I urge all the people, I sincerely urge all the people to come back and contribute, to this noble cause. Thank you.